We are at the 2019 NetEvent EMEA conference in Barcelona, and we have the pleasure to talk to Michael Kagan, who is CTO of Mellanox and one of the co-founder 20 years ago. Could you tell us how did you start the company?
So we started the company in '99. It was, for me, it was a special event because I was driving to the hospital where my wife just delivered our baby, and Eyal called me up, and I knew Eyal, our CEO, for quite a while. I actually managed him at Intel long ago, and he started telling me that let's start the company. So that's how it started for me. We started in the very small place that we rented. We built our furniture by putting the doors that we took out on the boxes, carton boxes of the computers, and that's how we started.
So, what was the problem you wanted to solve?
It's all about connectivity and networking. Basically, the network those days was fairly, I would say, naive. You have a single interface that is being used by multiple applications on the machine through the infrastructure of the operating system and the drivers and so on and so forth. And it basically creates fundamental bottleneck of how do you communicate across the network. So I was in the microprocessor business before that. I worked for Intel. I was managing the Pentium MX design team, and then one was leading the architecture of basic PCs. And it seemed to be much more exciting to me to make many processors work together rather than keep improving the single one.
What was the state of networking in those days?
Well, it was, I think it was start or in the midst of the 1 gigabit Ethernet ramp. And when we talked that actually our first product was 10 gigabit, and we believe that we need to drive a network performance much faster than traditional. People didn't quite agree with this or was so excited about this, and our drive there was much more based on intuition than on real data, because nobody really internalized, and actually we ourselves couldn't drill down to all the details. I just felt that we are in the beginning of some sort of transition. You know, I got my first phone at mobile phone. I think it was in 95-ish days, and it seemed to be as a start of some sort of transition of the way people work and communicate and running business. You know, all these great words about you know what actually makes our living on this planet.
What is the state of networking today, and where do you think you are heading with your technology?
Well, the networking, I think, it gone in the two lines in parallel. First of all, the raw performance of the network accelerated significantly. It accelerated significantly through the basically physical design. So, you know, you have more bits per second on the wire and so on and so forth, and you have data moving faster through the switch devices. But I think what is not less important is that it evolved to presenting much more efficient interfaces to the application. So the performance got to the point that you can do the qualitative and not only quantitative leap to do things very differently. So once all these services and the applications that were built around network were built under basic assumption that network is a bottleneck. If you need to access the resources over the network, you need to figure out a way how to reduce the amount of times you travel through the network and so forth. Once you have you have this leap ahead of networking, what you end up with is that there is no there is no limitation in alike. And once you break this wall, you get to the quality of life. You start being able to do things that you couldn't do before. So, and that has to deal with the saving not only the raw performance on the wire, but also the removing the fairly significant amount of software layers between the application, between different processes. And the next step, which is we started to drive it relatively recently, is actually also moving the data processing itself per se to the network. Not only enabling more efficient moving of the data between different process elements, but also providing the computing and data processing capabilities within the network, be it on the adapter or be it on the switches.
You said in your presentation that networking is becoming the essential part of the computing. And your new slogan is to think outside of the computer, which is a clear metaphor for thinking out of the box. Do you think it is going to change the way we are designing the computer tomorrow?
Yeah, I mean, what used to be the computer that people are explicitly programmed, now it is one of the elements of the data processing machine that actually being programmed automatically. If you think about the C code that is running on the x86 machines today, significant amount of this code is generated automatically and not written by people. So you put many machines together and you look at the problem at much more abstract way, and this problem is being broken down to individual pieces by synthesis tools. It's analogy with the VLSI design. We used to 34 years ago we used to draw the schematics by hand. Now nobody does it today. Okay, it's all being generated automatically from the much higher level abstraction of the logic that's described in the higher level language. The same thing happens with the applications that are being developed to deliver the services. You think people think at much higher abstraction layer and abstraction level and level of abstraction, and then all these things being synthesized to these data processing machines, which consists of thousands, sometimes of tens of thousands of von Neumann elements out there that are interconnected between.
Let's talk about your customers today. Of course, a lot of them are big supercomputer vendors, but you also have the hyperscaler, the one that operates a big data center. You have the media companies. Could you tell us a little bit more about all of that?
Okay, so first of all, there are two types of interconnect we are delivering. One is InfiniBand, another one is Ethernet. InfiniBand is basically the de facto standard for the HPC, high performance computing. I think our market share there is somewhere in the 80%. You can check it out with our marketing folks. If top 500 list is a bit confusing because people really use it for marketing purposes, and only maybe 50 or 100 fastest machines out there that are really built as HPC machines. All the rest is just, I want my name to see on the top 500. I put enough machines, put them together, and it works. The HPC is the technology, and the HPC on its own is the first step to the artificial intelligence. Basically, for years, the big machines are designed to run, among other things, basically neural network-like algorithms, be it visual or for medical purposes or whatever, scientific purposes or whatever. And now these things moves down or wider to the commercial space, and our technology is used in the artificial intelligence appliances that various people build. So this is the InfiniBand per se. Now InfiniBand enable a defined network on the wire / switch layer, but it also defined way the application interact or interface to the network and to their peers on the other side of the network. And we put this technology on top of Ethernet network layer. And this actually enabled us to enter the Ethernet market in, I think, toward 2010 somewhere. The first device was taped out in 2007. And we came up with the much more efficient Ethernet solution than any other technology vendors like Broadcom or Intel that were there for a while, because we brought the technology of application interface to network and application interaction over the network from much more advanced technologies InfiniBand than used on the Ethernet. So we are now leveraging the both worlds. We have very efficient application interfaces on our technology, and we leverage the scale and wide adoption of Ethernet to run on top of it. So in this space, our customers are pretty much all the big cloud guys. Some of them consider their infrastructure or their IT as the competitive advantage, so they don't let us mention their names explicitly, and they don't tell whose technologies they use. Some of them are talking about this publicly: Azure, Microsoft, Alibaba, Facebook. They all use our technology. Long time ago, I think it was in 2007 or maybe even earlier, Google published a paper in the the computing conference that you need to build your network based on InfiniBand, but since then they didn't publish anything else. But this was long ago. You asked about media. Media is another layer of data transfer that is now moving from some non-standard, I would say, or non-Ethernet technologies to IP. And at the end of the day, their problem is how to connect efficiently the cameras, which is application, say, to their processing elements, which is the the data center and so forth. And if you look at the core technology that is needed there, it's exactly the same that we have right now on our adapters and the switches. So our network is working and serving great. The media guys, what is the who's? Huh? What?
Grass Valley Group.
Grass Valley, yeah, Grass Valley Group. They're using our technology for their products.
You mentioned IoT in your presentation. What do you think are the challenges of these technologies today?
There's a lot of challenges in the IoT. The reason I mentioned IoT in the presentation is that the more data is being generated out there, and the more decisions are required to be made based on this data, it basically extends the data processing technology from the data center, which is this big buildings and big machines, all the way down to much higher volume of the more consumer-like technologies or products. Okay, so the reason I mentioned this is, and the challenges on this edge computing are exactly the same as in the data center, from the architecture and from basic concept. So we're better off using the same technology and the same software as we use in the data center when we extend it out, and that's why I mentioned it.
You've been acquired by NVIDIA recently. How are you going to operate inside this company, and what do you think is the synergy between these two companies, NVIDIA and Mellanox?
That's yet to be decided. I'm not sure that there's a multiple discussions about how to do it, but that's I think it's premature to talk about this before we become a single company. And in terms of synergy, if you look at NVIDIA and Mellanox, we have been working together for I think a decade, and we delivering the network solution that are making GPU to be the more efficient than any other network solution to scale out, and so we are truly complementary to NVIDIA.
To conclude this interview, what in your mind is the most important thing for your company to succeed?
Execution is good. That's what Andy Grove said in '92, I believe, in the different context. We believe that there's a lot of good ideas by many people, but if you can't execute and make it a real product, then that's one thing. The second thing is that actually, there are three things, okay? The second thing is that, we are not doing our best. It's like Churchill said, sometimes it's not enough that you do your best. Sometimes you need to do what's required. So if we set the target, we do whatever it takes to hit it. And the third thing is always to stay ahead of competition. The extension of Moore's law means that requirements are growing with time, and you can't just sit still with what you got. You always need to think not about the individual product, but about the roadmap and how you evolve it moving forward. Obviously not alone, but with the customers and partners, and learn a lot. Learn and learn. That's what it is.
Okay. Thank you very much. Excellent.
Welcome.
We will conclude with that positive note. Michael Kagan, thank you very much for your time.